Hi, welcome. On this video, we are going to continue with the lesson one, and this is the seventh point of this unit, radicals. Okay, so well in English we call radical to a root. Okay, so a root can have this way. So inside the radical, this symbol is the radical. There is the radicand. Okay, this is the radicand, and this small number is the index. Okay, the index. Well, in this lesson, we are going to work with radicals that usually don't have an exact result. Okay, so no exact result. Okay, maybe you have seen this before last year. So on this course, we are going to see with more detail the radicals and how to operate with them. Okay, so in first place, we're going to see some properties of radicals. Okay, well, I haven't said before, but radicals in English is also surds. Okay, it's the same name. Okay, it's the same meaning. So radicals or surds. So the first property that we are going to see is that we can transform any radical into a power. So the base of this power is going to be this number. Okay, so I write A. If we write here, if the radicand has a power, imagine that you have a power, that this is going to happen very, very often. Okay, so you are going to have usually powers in the radicands. So we write the m, the number that you have, over the index, over n. Okay, so let's see an example. So imagine the third root of 2 to the power of 6. Okay, you can write this as a power this way: 2 to the power of 6 over 3. As you see, we can simplify the fraction. So 2 to the power of 2, that is 4. Okay, so in this case, it's a exact number. Okay, well, another property that we are going to see is when you have different radicals together. So in this case, what you have to do is to put everything in the same radical, and the index is going to be the multiplication of the indexes. Okay, so let's see an example. So the fourth root of the square root of 2, this is equals, well, be careful, because when we have a square root, we don't write the index 2. Okay, so we don't have to forget that here there is the number 2. Okay, I'm going to write, but remember that you are not going to see this number. Okay, so 4 times 2 is 8. The new index is going to be 8, and in the radicand we'll get the number 2. Okay, if we want to transform this into a power, we will write 2 to the power of we don't have any number, but think that this is 1, okay? This is 2 to the power of 1. So don't forget to write the 1 when you don't have any power. And so 2 to the power of 1 over 8, okay? The third property that we're going to see is in case you have multiple powers. So imagine that you have this, and in brackets you have another power. Sorry, here I'm going to write another letter, for example H, okay? So if you want to simplify this, it's very easy, okay? So we write the radical with index n, and in the radicand we write a to the power of h times m, okay? So we can remove this exponent. We put the exponent down in the radicand and we multiply the exponents, okay? So let's see an example. So you have the square root of 6 to the power of 3, and all the radical is raised to the power of 4, okay? So I'm going to simplify this. 6 to the power of 3 times 4 is 12. Okay? So let's continue. Now we are going to learn how to simplify some radicals, okay? So let me see this, okay. Well, imagine that you have this. Let me see, okay. We're going to see an example. So if this is the fourth root of 2 to the power of 2, and all the radical is raised to the power of 6, okay. Well, we have to simplify this. So we put everything into the same radical. So the index is 4, 2 to the power of 12. And now, this is not going to be the final solution, because when you have an index, an exponent like this, we have 4 in the index, 12 in the exponent, we can simplify both. We can simplify index and exponent dividing by the HCF, okay? Dividing by the highest common factor. So in this case, we can divide by the number 4. So sorry, I'm going to remove this. Okay. So it's left 2 to the power of 3. Why? Well, if I divide by 4, 4 divided by 4 is 1, so I can eliminate the radical, and here in the power, 12 divided by 4 is 3. So this is the final result. I can eliminate the radical because in the index is left the number 1. Okay, let's see another example. Now with multiple radicals. I'm going to write a letter now. x to the power of 12. So we have to simplify this. To simplify this, we write an only radical. I have to multiply the indexes. So 3 times 2 is 6, okay? Remember that this is a square root. Don't forget there is a number 2 here, okay? So 6. And into the radical is left x to the power of 12. Well, of course, we can simplify this. We can divide index and exponent both by 6. So if I divide the index by 6, 6 divided by 6 is 1, so I can eliminate this. This is 2, so x to the power of 2. So this is the result. Okay, so that's all.